Welcome to the Explainer. Today we are taking a journey deep inside your car to demystify one of its most essential systems, the drivetrain.
I mean, have you ever really thought about that? How does a relatively small engine move a machine that weighs 2 tons? Well, it's all thanks to this remarkable chain of components called the drivetrain. It's the system that takes the raw power from the engine and actually delivers it to the road. So come on, let's follow that power, starting right from the source. Okay, our journey begins right in the heart of the engine, where literally thousands of tiny, controlled explosions every single minute are being harnessed and turned into useful motion.
So inside the engine, you've got pistons firing up and down like crazy. The crankshaft's job is to grab that chaotic up and down motion and turn it into rotation. But that rotation is super jerky. That's where the heavy flywheel comes in. Think of it like the engine's pacemaker, smoothing out all those powerful pulses into a steady, usable flow of power. From there, it's ready to meet the clutch, which is basically the gatekeeper for the rest of the whole system.
And that brings us to the first really critical control point in this journey, the clutch, at least in a car with a manual transmission. The clutch's job is actually pretty simple, but it is absolutely vital. When your foot is off the pedal, a powerful pressure plate clamps a friction disc right up against that spinning flywheel. That locks them together and lets the power flow onwards. The second you press that pedal down, though, the connection is broken. It's really just a powerful on-off switch that lets you, the driver, momentarily disconnect the engine from the wheels so you can shift gears.
Okay, so why do you even need to interrupt the power in the first place? What's the point? Well, the answer to that lies in the gearbox.
Here's the thing. An engine is kind of picky. It only produces really useful, efficient power within a very narrow range of speed, what we call RPM. It has a sweet spot. But the real world of driving, starting on a steep hill versus cruising down the highway, demands a whole range of speeds and power. And gears solve this problem perfectly by acting as translators. A large gear driven by a small one multiplies the engine's turning force. That's the raw muscle or torque you need to get moving from a stop. Then, a small gear driven by a large one delivers more speed. This whole system is what lets the engine stay right in its happy, power-efficient sweet spot, no matter how fast you're actually going.
But how do you avoid that horrible, cringeworthy grinding sound when you shift? That's the job of a true unsung hero, the synchronizer. It's this clever little friction cone that perfectly matches the speed of the gear you're about to select to the speed of the shaft before they actually lock together. It's this one simple component that makes smooth, modern gear shifting even possible.
Of course, these days, most cars handle all of this translation work for you automatically. So let's take a quick look at the 3 main types you'll find out on the road.
All right, this table kind of breaks it all down. The traditional automatic transmission uses a fluid coupling called a torque converter instead of a dry clutch, and that's why taking off from a stop feels so incredibly smooth. It's really all about comfort. Then you have the continuously variable transmission, or CVT. This thing is wild. It ditches gears completely for a system of pulleys and a belt. This gives you perfectly seamless acceleration. It feels like you're in one long gear. And finally, the dual clutch, or DCT. This is basically 2 automated manual gearboxes working together. It pre-selects the next gear before you even need it, giving you those lightning-fast shifts you see in performance cars.
So, the power has been translated by the gearbox. It's been converted into either muscle or speed. Now, it's finally time to deliver it to the wheels and hit the pavement. Okay, but think about this for a second. When you make a turn, the outside wheel has to travel a much longer distance than the inside wheel, and it has to do it in the exact same amount of time. So how do they both get power without fighting each other and making the tires just screech and skip? The answer is this absolutely brilliant piece of engineering called the differential. Using a super clever set of internal gears, it splits the power coming from the drive shaft, but, and this is the magic part, it allows the outside wheel to spin faster than the inside one during a turn. It really is the diplomat of the drivetrain, preventing conflict and making sure you have a smooth, stable corner every time.
And there it is, the entire journey, all laid out, from the crankshaft's very first rotation, smoothed out by the flywheel, engaged by the clutch, translated by the gearbox, sent down the drive shaft, split by the differential, and finally delivered to the wheels. It's just an incredible, perfectly coordinated flow of power.
This whole intricate mechanical dance is a symphony of gears and shafts that's been perfected over more than a century. But as we move toward an electric future, this entire journey is being completely reinvented. An electric motor delivers instant power at any speed, so it doesn't need a complex gearbox at all. So the final thought is this. As we gain all this new efficiency and simplicity, what, if anything, do we lose from this incredible mechanical story?